everyone, welcome to Maths IEC. Here is a typical GCSE exam style question, GCSE and IGCSE exam style question on electricity. So a circuit contains two bulbs connected in parallel to a 12 volt supply. You can see it on the diagram. The total current from the battery is 2.5 amps. The current through bulb 1 is 0.85, and they have asked some questions about this circuit. Some of the questions are relatively straightforward, and some of the questions are really good, especially I think the last one. Please pause the video and give it a try. When you're ready for the answer, press play. The first part is, what is the current through bulb 2? Now, we know the current that goes through this branch here is 2.5 and bulb 1 takes 0.85. The current through bulb 2 is obviously 2.5 take away 0.85 amps. So we know this is 1.65 amps. That is the answer to the first part. Second one. What is the voltage across each bulb? Now this is very straightforward. This is a parallel circuit. In a parallel circuit, the PD across each branch remains the same. So since it's a parallel circuit, the voltage across each bulb is 12 volts. What can you conclude about the voltage in a parallel circuit? Voltage across each branch is the same. If bulb 1 burns out, how will this affect the voltage across bulb 2, if at all? Well, if bulb 1 burns out, the voltage across bulb 2 does not change. Last part. Will the overall current in the circuit change if bulb 1 stops working? Justify your answer. Now, this is a good one. So let me just elaborate a little bit more on this one. Say, when bulb 1 stops working, this one literally does not exist, right? Maybe the filament breaks or something. Now, when there is no bulb 1, there is a gap in the circuit. So, there is no current through this branch. The circuit does not draw that 0.85 amps of current. What that means is, the total current that is coming out from the power supply is not 2.5 amps anymore. That is just 1.65 amps. So the current goes down. So what happens is, it goes through this one, 1.65, goes through this, goes through this, goes through that, and goes through this. So the bit I'm highlighting here, all of that, there will be no current through it. Now previously, the circuit drew 0.85 amps on top of 1.65 because that was needed for bulb 1. Now bulb 1 does not exist anymore, or it's broken. So, will the overall current in the circuit change if bulb 1 stops working? Yes. What will happen is the overall current will be 1.65 amps. Now, I've seen some people say in the exams, or it will be more, or it will be less. But you can really be specific here. If bulb 1 blows, you can clearly say the total current will change to 1.65. So, as the answer you can write, yes, the overall current in the circuit will be 1.65 amps as there is no current through bulb 1. The overall resistance of the circuit is now greater than before. Therefore, the total current will be less than before. Now, in a series circuit, if you remove a resistor, the total resistance decreases. But in a parallel circuit, it's the other way around. Now, let me explain this a little bit further. We're kind of done answering this question, but here's the idea. If this is 2 ohms, 3 ohms, and 5 ohms, and if I remove this one, you remove it. Now you go 2 ohms and 5 ohms only. Now, the total resistance here, R total, is 2 add 3 is 5 add 5, 10 ohms. The total resistance here is only 7 ohms. So removing a resistor in a series circuit will reduce the overall resistance. However, in a parallel circuit, the situation is a little different. So in a parallel circuit, imagine you have a 5 ohm resistor in parallel with another 5 ohm resistor. And here you remove one of them. Now it's just only one 5 ohm resistor. Now, the total resistance here is 5 ohms. In GCSEs, you don't really need the formula to calculate the total resistance. I can just mention this as a kind of an extension here. So there is a formula called 1 over R total is 1 over R1 plus 1 over R2. So these are just the resistance of each value. So if you just put this one, you can see 1 over R total is 1 over 5 at 1 over 5. Now, when you simplify it, you can see 1 over R total is 1 over 5 over 1 over 5 is 2 over 5. So if 1 over R total is 2 over 5, the total resistance of this first part is actually 5 over 2, which is 2.5 ohms. Now, when you have two 5 ohm resistors in parallel, the total resistance is 2.5. When you remove one of them, it goes up. Now, you don't really need this calculation at GCSE level. I just did the calculation just to prove the point. So the idea is you need to know, in a series circuit, if you remove one of the resistors, the total resistance will just go down. In a parallel circuit, if you remove a resistor, the total resistance goes up. Now, to understand this in a more GCSE friendly and qualitative way, right? Think about it like this. The resistance is about how hard for current to get through a certain path, the opposition of a component to the flow of current through it. Now, the current through this one here, the current will just go like that here. All of the current will have to go through this one. In a parallel circuit, when you have two resistors like that, the current now has two paths to go through. So obviously, it will be a little bit easier than going through one. So that's why we can think in a parallel circuit, when you have number of paths, number of branches, the overall resistance is lower. But for this question, you don't really need all of that. So all you need to understand is once bulb 1 is not there, once bulb is burnt out, this 0.85 isn't there. So there is no reason for that current to come out from the power supply. So it will only draw 1.65 amps, which is needed for the second bulb number 2. So you can clearly see when you remove the first bulb from the parallel circuit, the overall current decreases because the overall resistance of the circuit is now greater than before.